Hey everyone, my name is Isa, and I want to just give a little brief introduction to variables in C++ and also in other languages. So, what are variables? Variables are containers, basically. You can think of them kind of like little boxes, and their whole purpose is to contain a value. So, let's just make one. So, the first one we'll talk about is an integer. Integers are whole numbers, so integers, whole numbers can be positive and negative. So how do we make one? Well, in C++, you say int for integer, and you give it a name. So let's call this, I don't know, number. And let's give it a value. So I like to give it the value 5, just why not? So when we give it a value, we are saying, hey, take this number 5 and store it inside this variable called num. Now if I open up a pen tool, what's really happening under the hood is, so let's say this block represents memory in our computer, and when we say int num, we're basically making a little box in memory to hold the value 5, and this box is called num. And that's kind of what we're doing. So every time we use num in our program, it's gonna reference this box right here. It's gonna be like, hey, okay, so we want this piece of memory, which holds the value 5. So when we do this line of code, what we're doing is we're declaring a variable. That's the int num part, and then initializing it, that equals 5. I would recommend initializing all your variables, just because you never know what's in there if you don't initialize. So if we did this, for example, now we don't know what's in here. There could be something in here, or there could not be. You know what I mean? So like this could just be an empty. This could be empty. Oh god, I can't even. Let me redraw that whole thing. So this could be empty. There could be nothing in it, or there could be some values from a previous program or whatever that already like used it. So always initialize it. And generally, I like to initialize it to 0. But also, like sometimes if you know what number you want it to be in the beginning, you can do that. So what about decimals? So we have two kinds for decimals. So we have floats and doubles. And these are decimal numbers. Not like base 10 decimal. I mean like, like with the decimal. So like 5.5 for example, etc. So you have two. For our purposes, we're going to treat them pretty much the same because they look the same, but doubles are larger than floats. And if you look in the description, I'll send you this little piece of paper, or not a piece of paper, but it's kind of like a type up. I just wrote this a while ago, and it basically walks through this. And there's actually one section where I prove to you that this is a lot larger. The double's a lot larger, and the way I did that was by getting its maximum number. So the maximum number you can store in a double is this number. It's huge, while a float is only this much. So a double is twice the size of a float, aka a double, which is kind of the name. So anyways, you kind of work with them the same way you would work with an int, except you just have a decimal. So if I say a float x is 5.5, we can verify this by counting. So if I count, let me count num, and let me count x. So if I run these, cool. This is num, this is x. If we try to add a decimal to num, and I run this, you see how it's even though we added a decimal, it kind of chops it off, and it doesn't round. That's something that some people mistake or assume. It doesn't round, it just chops it off. So yeah, that's kind of the difference between floats and ints. And of course we can do the same thing with a double. So if I say double y, and let's use some other numbers. Let's do 28.4. So if I do the same thing, but I change this to Y, it works pretty much the same. So realistically, you're probably not going to use, it's not going to matter the size in an academic context, but I guess if you're working, like let's say you're working with NASA, you're trying to get rockets, into the space or whatever, and you really need that precision. You need to know, like, I don't know, some number to like the 20th decimal place. I don't know. That's kind of where this versus this would factor into your decision making. Yeah, we'll come back to this in a later concept. The other thing I want to talk about is text. So text in C++, and we're gonna go really in depth into one of them, but we have this thing called characters or chars. Chars, characters, they represent letters. Represent letters in code. So the first thing I should probably talk about is, hey, we have this thing. It's a really cool website called ASCII Table. So if we take a look at this, it basically tells you the ASCII value for every character, every key in to a computer. So the way that text works in a computer is that the computer doesn't actually read, std : count. They read numbers, more specifically in binary. But if we look at this, there's a way for us to convert the text we have. So like, say like, I don't know, A. Capital A is 65 in decimal, and you can convert that to binary, and that's what the computer will recognize. So every time you press the A key, the computer is saying, oh, we got this number 65 in binary. So, oh, he must want this key. And so that's kind of how the computer works. So we can take advantage of that, and we can do that. We can do stuff with chars. So when I say, so let's just make a char for a second. So char, give it a name. I'll say letter, and I'll give it a value. So I'll give it A, capital A. So computer is reading capital A as 65 in decimal, in like our number system. So this is like useful because now we can compare. We can work with this value, and the computer itself can interpret it. That's just kind of how text works. We'll go really in depth in text in a future video. Just want to throw it out there. You can also do stuff like this. So if I say letter equal to 65, because letter is a char, you know what? I don't even know. Will it work? Let's see. So if I print this, yeah, it prints A. So let's change it to, let's look at another value. Let's say like 70. So let's change this to 70. Let's say 70. If I run this, F. So now we're looking for 70. So here's 70. There's capital F. So you can either work with characters directly with this like single quotation thing, or if you know the ASCII value, and I'll just leave a comment, ASCII value of F, you can also give it numbers. So that's kind of cool characteristic of characters. So yeah, those are characters, which are pretty nice. They're good for menus. They're good for lots of things. But what about actual text? What about like, a whole like here I gave a little sentence, program ending. How do we do that in a variable? Well, in C++, there was something called a string, which is a string class, a string class. And we'll talk about classes later. Don't worry too much about that. It's just basically a variable. It's called string, so std string. By the way, if you don't want to type std every time, you can also say using namespace std. It's just going to assume that you're always talking about std. So if I take out the std, it's going to be like, oh, we're string. So string, and we can give it a name. So let's call it, I don't know, text. And let's give it some initial text. And by the way, notice we're using double quotes for string, but single quotes for character. And that kind of makes sense. That's kind of like a thing it'll get intuitive. So, anyways, let's do some text. So, I am Isa. That is my name. And we can do the same thing. We can count it. So let's count text. And it works as intended. Now, we're going to talk a little bit more in detail about the string class and how it works. And there's also a way you can use chars to represent multiple like text. And it's something called the C string if you want to look ahead on that and check it out. But for now, these are variables. And there are a couple more variables that we can talk about. But I think for now, this is a good starting point. Remember that this can be used in any language. Most of these are universal. In languages like Python, you might not even need to call to like give the type of the variable, which is this thing. This is the type of variable. So generally, just for like reference, you make a variable by following this format. So the first one is the type. What type is that variable? So if it's a string, we give it a type string. If it's a char, float, int, all that. The second thing is our name. What we call it in the program. And by the way, you cannot have two variables of the same name, because then the computer gets confused and it's like, I don't know what you're trying to work with. And then the third thing is optional. And it's basically, do you want to give it a value? Initial value. So what happens if you already have a variable? And we kind of did this here. So we made a variable, we declared and initialized a variable called letter, and then we reassigned it. This was a reassignment. So what happens when we do this? Essentially what we do is we override the previous value. So in this case, we had the A, we initialized it with A, and on line 21, we overrode that value. We changed it. Remember, the computer reads from top to bottom. So whatever comes after, this is what gets counted. So, when we run this, we get F instead of A. And just to make this more readable, I'll just put it like this for a second. So, you see how this is kind of grayed out? Because it's like, yeah, we're not going to use this. Because C-line is smart. My IDE C-line is a little smart. It's like, hey, you never use this value. And you can do that with anything. So I could change this here. I could say X is equal to 20.5. And now if I run this, we'll get 20.5. You cannot use variables before they are declared. This will give you an error because, as we know, compiler reads top to bottom. So if you try to use it before you make it, it's going to be like, I don't know what that is. Yeah, I think that's it. So I hope this was helpful. If it is, please leave a like, and I'll see you in the next video.